We saw that the amount of money owed on a loan after T years in which we originally borrow P0 dollars with an annual interest rate of R compounded n times per year is given by the formula P of T equals P0 times 1 plus R over n to the n times T. In our first example, we saw that the amount of money owed on a loan after T years in which we originally borrowed $10,000 with an annual interest rate of 6% compounded monthly, or 12 times per year, that it was given by the formula P of T equals 10,000 times 1 plus 6% over 12 to the 12t. Furthermore, we notice that as we increase the number of times per year that interest is compounded, then the amount owed increased as well. And looking at different values of n, we started with n equals 1, just compounding one time at the end of each year. Here, the amount owed after 1 year was given by 10,000 plus 1 plus 6% over 1 to the 1 times 1, which came to $10,600. Once we increased the number of times per year we compound interest to 12 and did it every month, then the amount owed after 1 year was given by 10,000 times 1 plus 6% over 12 to the 12 times 1, which came to roughly $10,616.78. Now, what happens if we compound every day and n is 365? Then the amount owed after 1 year is 10,000 times 1 plus 6% over 365 to the 365 times 1, which comes to roughly $10,618.31. It's increased a little bit from compounding every month. And what if we go even further and compound every second, which means that n is 525,600? Then the amount owed after 1 year is given by 10,000 times 1 plus 6% over 525,600 raised to the 525,600 power, which comes to roughly $10,618.37. Again, it's increased a little bit from compounding every day, but not by that much. And what if we compound 1 billion times in a year? Then the amount owed after 1 year is given by 10,000 times 1 plus 6% divided by 1 billion raised to the 1 billion power, which, if we round to the nearest penny, comes again to about $10,618.37. It actually did increase from the last one, but by so little, it didn't even add another penny. So we notice that as n increases, so does the amount owed after 1 year. However, the amount owed, P, increases by a smaller and smaller amount. And eventually there is no difference when rounding to the nearest penny. So what's the significance of this number, $10,618.37? It can be shown that this amount that P settles on is given by the formula P of T equals 10,000 times E to the 6% times 1 year. And in general, the amount of money owed after T years is given by the formula P0, the original amount borrowed, times E to the R times T, where E here is an irrational number that's roughly 2.718, although it continues forever. In this case, since interest is compounded more and more, even infinitely often, we say that the interest is compounded continuously.